Hello, Mr. Munyon here with activity 39-1 using Venn diagrams to represent sample spaces. So in this activity, our goals are to represent events using Venn diagrams, as well as convert Venn diagrams of counts into Venn diagrams of probabilities. So make sure we fully understand Venn diagrams and then use those to come up with some probabilities. So in this first example here, we already hopefully know what sample spaces are using tables. We're going to look at a sample space of students at Annabelle High School. S is going to represent the students that are taking Spanish. A is representing the students that are taking art at the school. And you'll notice they're in the Venn diagram. It's called a Venn diagram because there are some overlapping sections here. So we can see there's some that are only in the circle for S and not in the circle for A. There's some that are in both circles. Same thing over here. And there's some that are in neither one of them. You know, maybe that represents students that aren't taking Spanish and aren't taking art. They're neither one of those classes. So then let's make sure that we fully describe these situations as we answer these using complete sentences. It says, look at the number 112 in the diagram. This number is inside the circle for S and outside of the circle for A. It tells us there's 112 students who take Spanish but do not take an art class. All right, so we see here that's in the circle for S, but it's outside of the circle for A, for art. So we know those students are in Spanish, but they're not in art. What does the number 98 tell us? So 98, there are 98 students who are taking art, but not taking Spanish. What about the number 84? What does that tell us? Well, that's in both the circle for Spanish and in the circle for art. So there's 84 students that are taking both art and Spanish. What about the number 56? What does that tell us? And 56, those are students that aren't in either of the circles. So those are students that are not taking Spanish and not taking art. And the reason I phrased it like that with and is because we in the last section learned about and or. You wouldn't phrase it as those are students that are not taking Spanish or art because or means it's more inclusive. The students that are not taking Spanish would be represented by everyone not taking Spanish. And then when you say or, we add more to that. Or not taking art, we'd say, oh, these students included. So it'd be everybody but 84 students. So we phrase it as the students not taking Spanish and not taking art. So they have to be outside of both of those circles, and that's just the 56 students that aren't taking Spanish and aren't taking art. All right, 56 students not taking Spanish and not taking art. And what is the total number of students who take Spanish? So to find out the total number of students that take Spanish, we need to look at both of these categories here to make up the whole circle for Spanish. So we just need to add those together. And 112 plus 84 does equal 196 for the total number of students that are taking Spanish. Because some are just taking Spanish and not art. Some are taking both Spanish and art. All we do is add them together and get 196 for the total number of students taking Spanish. Moving on to the next section, what is the total number of students in the art class? Same thing, we can just add up the two here and we'll figure out how many total students. It should be 182 when we add those together. And for the next one, how many total students are there in the whole school? We just add up every student, whether in just Spanish, if they're in both Spanish and art, just art, or not taking either one of those. We get 350 total students. How many students at the school take Spanish or an art class? So, or, remember, we include any other groups of students that fit that criteria. So how many students take Spanish would be this group here, that 196 that we got earlier. And what else are we looking for? Or an art class. So or an art, are there any other students that are taking art? We haven't already counted the 98 students here. So if we add all of those up, we do get 294. And the last question in this section, how many students do not take an art class? So how do we figure out how many students do not take an art class? We just add up the pieces that are not in art. So 112 and 56, we get 168 for that one. Okay, so Venn diagram, pretty easy. There's just different regions that represent, a specific event happening, and sometimes they could overlap because both events could happen. And there's also a region outside of both of those events as well that represent neither of the events happening. Okay, so now that we know how to use the Venn diagram with the counts, let's look at it in terms of probabilities. So, all right, probability that the selected student takes Spanish. We know there's 196, so probability to take Spanish is 196 Spanish students out of the 350 in the school. Plug that in our calculator and we get about 0.56, or about 56% if you write it as a percentage. Okay, for art, we could do the same thing. Take the total number of art students, or the part that represents the art students out of the total school. So probability they're in an art class. It's going to be how many art students were there total? Looks like 182 art students out of 350. So 182 out of 350. Plug that in our calculator and we get about 0.52, or 52%. We can do the same thing now with these. All of these will be out of 350. So Spanish and art. That was 84 students here were in Spanish and art, so 84 out of 350. And plug that in our calculator, we get about 0.24. Takes an art class but does not take Spanish. So art class but not in Spanish would be 98 out of 350. And in our calculator, that rounds to 0.28. Spanish or art, let's see. Spanish or art, that was 294 that we came up with out of 350. And plug that in our calculator. 294 out of 350 should be 0.84. 84%. And last one takes neither Spanish nor art. They're not in either one. That would just be this 56. Those are the students that are not in Spanish and not art. 56 out of 350. And that's 0.16, or 16%. Okay, so obviously practicing with our notation here is good to make sure we're correctly using that notation. We need to know how to take each one of the fractions that we come up with, convert it to both a decimal and a percentage, because we could see those in any of those forms. Let's now practice more with a Venn diagram with just probabilities. So it says often we write the probabilities in a Venn diagram rather than the counts. A lot of times it's more useful to actually have the probabilities. So suppose that a student selected at random from Annabelle High School. Let S be the event they're in Spanish, A is the event they're in an art class, and here we have some probabilities filled out here with some blank ones. So it says the number 0.32 in the set tells us the probability that the selected student takes Spanish but does not take art. How do we calculate this probability? We use the numbers from the count. So remember there's 350 total students. If you take 112 over 350, we get about 0.32. Let's just check just to make sure. 112 out of 350. 112 out of 350, we do get 0.32. So obviously that's where that 0.32 came from. How do we calculate that probability? Oh, that's what we got, 112 out of 350. So the part that represents that event happening over the total number of events in the sample space. So B says, what does the 0.56 represent? Well, notice the 0.56 here is outside of the sample space because it includes more than one region on this Venn diagram. It includes the entire circle for S, both the students that are just in Spanish and not art, and also includes the students that are in both Spanish and art. So I would have to add these together. So that represents the probability that a student is in Spanish, regardless of whether they're in art or not. It doesn't matter. It's just the overall probability that they're in Spanish. So the 0.56 is the probability that a student is in Spanish. Okay, write the appropriate probabilities for the remaining in the box. Write the appropriate probabilities in the remaining empty boxes. So 2 ways we could do this. We should be able to take 84 out of 350 and get this value. So we could do that. 84 out of 350 gives us 0.24, but also notice that that is the sum of the two probabilities. 0.56 is the sum of those two individual probabilities. If there's a 0.32 chance that they're in Spanish but not art, and there's a 0.24 chance that they're in both Spanish and art, you can just add those together. You get 0.56 for the total probability they're in Spanish. Okay, let's go ahead and do these other out of 350 just so we have, and we'll check this one the same way. We'll check the probability there as well. 98 out of 350. Let's see what we get. We get 0.28. If I add those together, it should be 0.52. And if I took 182 out of 350, just to make sure, it should be 0.52. So 182 out of 350. Hey, look, it is 0.52. So conveniently, we have a couple of ways of figuring out some of these values. The last one should be 56 out of 350, which is 0.16. All right, and all of these values inside of here should add up to 1 because that represents every possible student. Now notice we aren't using these values as the total, 0.32 plus 0.24 plus 0.28 plus 0.16. The ones that I circled there in blue here should add up to 1. Why do we not include these? Because these include values that, one, they've already been counted here and here, so that 0.56 doesn't need to be counted again. But these two together have a region that overlaps. If you counted this and this, you'd be counting this 2 times. So we don't want to, double count something. This is each individual region that's not overlapping being counted 1 time. So 0.32 is just the students in Spanish not taking art. This is the count represents the students that are in both classes. This is just art, not Spanish. These are the students that aren't in Spanish or art. This includes multiple regions. So if we added these in there, it would count regions more than once. Let's now look at a new problem. Question 4 says the most popular color for vehicles is white. Suppose that a vehicle is selected at random from a city. Let C be the event that this is a car. So I'm going to go ahead and put car on there to make it a little bit easier. And W represent that the vehicle is white. Okay. Some of the relevant probabilities are shown. What 2 probabilities do you add together to get the probability that the vehicle is a car? So this whole region here represents the car, so I add those 2 together. 0.62 plus 0.14 equals, what is that, 76? So probability it's a car, it should be 0.76. Okay, next page. Got the same diagram. Find the probability selected vehicle is white. So we can do the same thing. So 20% probability for that. What about being a white car. So this one's interesting. To be a white car, it has to both be white and car. That would just be the region in the middle. So the probability that it is both white and a car is 0.14. To be a white car, it has to be both of those, white and a car. For the next one, a car that is not white. So probability that you have a car not white. Well, a car but not white. These are cars that are not white. These are cars that are white, so 0.62. What about being a car or is white? So being a car is all of these, or is white. We can add that to it as well. So we get, what is that, 0.82. We can add up all three of those to get probability of it being a car or white. And we have another one. Oh yeah, looks like we got one more down there. What region in the Venn diagram represents the event that a vehicle selected is neither a car nor white? That would be the region that's outside of both of the circles for car or white. You know, this region out here. Find that probability. Well, we know that all of these probabilities need to add up to 1, so we could just take 1 minus 0.62 plus 0.14 plus 0.06, and whatever's left will be this region out here. So we get 0.18. So 0.18, which is the complement of that right there. So since we already added these up to get a car or white, anything else would be the complement of that. So it should be 0.18. All right, now we've gotten to a point that you should be able to practice some of these on your own. So I want you guys to try number 5 through 7 and see how you guys do. And I'll come back and work these to make sure that you did them. I won't just show the answers. I'll go ahead and work them as well. All right, hopefully you got through number 7. Let's go ahead and answer these. Number 5 says at the beginning of the activity we're given a Venn diagram with the numbers. I went ahead and put it off to the side here so we can see it. And let's go ahead. How did we, from the counts we were given, how do you calculate the following? Total number of students at the school, you add up all of these regions to get 350. Probability that a randomly selected student takes Spanish. You have to add up the students that are in the region for Spanish and then divide by 350. The part that represents them being in Spanish is both of these two regions. You get 196 out of 350. How did you find the probability that a randomly selected student takes an art class but does not take Spanish? That would just be this region out of 350. So we'd be selecting 98 out of 350 for that one. And you do get 0.56 and 0.28 for those two. Okay, number 6 here says, suppose that a student will be selected at random from Annabelle High School. Let A be the event they're in an art class. B is the event that they play basketball. Let the quantities P, Q, R, and S given in the Venn diagram represent probabilities. So this is important. It tells us they already given us probabilities, not counts. So how would you calculate the probability that a student plays basketball? We could just add these two probabilities up, Q plus R. Okay, and since they're probabilities, we don't have to divide out of the total because the total probability would just be 1 in this case. We don't have to find the total number of students to do this. They're already probabilities, right? What about a 2? Takes an art class and plays basketball. That would just be Q. These are students that are taking art and playing basketball. Okay, what about plays basketball but does not take an art class? Plays basketball but not an art. That's just R. Takes an art class or plays basketball. That would be takes an art class would be these two. Or plays basketball. We can add any other regions we haven't counted already there. That'd be P plus Q plus R. And what about does not take an art class? So this one's kind of interesting. Where can we find the regions that are not taking an art class? Both of these two. So R plus S. Those represent students not in art. All right, if you knew the values of P, Q, and R, how would you find the value of S? And what does that probability represent? So if I wanted to find S, I could just subtract P, Q, and R from 1. So to find S, it equals 1 minus P plus Q plus R. And that represents the students that are not taking art or playing basketball, and not playing basketball. They're not art nor basketball. Number 7 says, suppose that a student will be selected at random from Annabelle High School. F is the event that they play football. And M is the event that they take a music class. And figure out some of these probabilities. So it says complete the diagram. Remember this one we can get right here. The 0.21 has to be the sum of these two regions. So that's just going to be 0.03. And since I know this now is 0.03, I can add those together and get 0.80. And how can I find this probability out here that's not listed? 1 minus these other ones should give me what's left. So 1 minus 0.18 plus 0.03 plus 0.77. And what is that? 80, 18, so 98.02 total for that. So complete the diagram. What is the probability that the student will play football but will not take the music class? So football, not music, should be 0.18. What is the probability that the student will take a music class? Should be 0.80. All right. So both of those were pretty reasonable. Let's now, on this section, I will pause here. You can pause here for a moment, and then I'll just put the answers up so that you can check your work. I may explain a couple of these if they have some tricky ones. Okay, here are the answers. This was Kennedy High School, not Annabelle High School, so the total number did change. It was out of 240, not 350. So when you got down to the question 9 with the probabilities, you did need to use out of 240. If you need to pause and check your work here, go for it. I did show a little bit of work down at the bottom with the probabilities, so you know where they came from. I did want to, however, look at question number 10 and work this one. So on 10 it says, suppose that a student would be selected from the high school arts and sciences. Let P be the event that the student takes physics and D be the event that the student takes dance class. So P is physics and D is dance class. Okay, the probability that the student takes physics is 0.28. And that's for the whole circle, so I'm not going to be just one of those. While the probability the student takes a dance class is 0.45. The probability that a student takes physics and dance is 0.07. And that's the region where they overlap. What is the probability that the student takes a dance class but does not take a physics class? So this is what we're trying to find. We can get that by remembering these two probabilities here have to add up to equal this probability. So 0.45 minus 0.07, we get 0.38. This region, and that region are the students that are in a dance class that are not in the physics class. So 0.38 should be the answer we're looking for on that one. All right, now that we've finished this section, should be prepared for 39-2, the next lesson. See you guys there.